So we're chapter 8 practice test. First 30 we could get from yesterday's video on A5B, but if you have pressing concerns, I would tell you. Anybody up through to 30 of the vocab need anything to get done for sure?
What are the two things for empirical and molecular?
Empirical was the simplest formula, and it was like the smallest whole number ratio. Anybody else something vocabby?
And then what's the molecular?
Molecular shows the actual number of atoms, and it's a whole number multiple of the empirical. Anything else? 12. Same number, but grams instead of AMUs. Anybody else vocab life? Alright, so math life. 1, 2, 3 basic idea is that the vocab answer about multiply and subscripts and atoms and AMUs and add them all up. That answer, that's what we're doing here. So we're going to round these to the tenths. We're not going to do anything with significant digits on this first 8 questions. Just round everything to the tenths place when we use the table. 1 through 3 is 180 AMUs. 2 is 74.1 AMUs. The third one is 342.3 AMUs. Keep going and do the same stuff, but when we get to number 4, say grams, but do the same math. It's 111.1 grams, 324.6 grams, and 310.3 grams. Can I help you with any of that math? Anybody fall short in any way? Number 6. So I'm going to go calcium is a 40.1, rounded from 40.08 to 40.1, times 3. Phosphorus is a 31 even, times 2. Chemistry doesn't believe in distributing, but those parentheses with the 2 after it, that's basically what you're doing. That 2 needs to multiply every number in the parentheses, so there's 2 P's. And the O's, there's 8, so 16 times 8. And then add up those results.
Okay, thank you.
Yep. Anything else I can do on 1 to 6? 7 is so easy, it's silly, it's even a question. The nitrogen has 2 and oxygen has 4, because you just look at the subscripts and that tells you if you have 1 mole of whatever it is, the subscripts tell you how many moles of each atom you had. For the second one, barium has 1, calcium has 4, or carbon has 4, hydrogen has 6, oxygen has 4, and then I'll pause there. Anything up to 8? 9. Some of you don't like dimensional analysis. I'm telling you wholeheartedly, dimensional analysis is the best way to do these problems. Can you sometimes read it and just know you should multiply by this or divide by that? Probably. If you live your life on the multiply by this, divide by that, hope for the best strategy, you will get disappointed a lot of the time. The dimensional analysis will make it very clear who should go on the tops and multiply and who should go on the bottoms and divide. Other than that, you're just relying on a series of 50-50 guessing at times, and if you have 3 50-50s, you got a 1 out of 8 shot to get that right. If it's a 4-step problem, you have a 1 out of 16 shot to get that right. So I would not base my life on that scheme. But I'll do some dimensional analysis on the board if that helps people, or talk you through it if it doesn't. But starting on 9, we're looking to go 3 significant digits, and we're also looking for a unit, which also includes a substance. So for number 9, answer I'm hoping for is a 0.169 for the number, but also say moles and put Al for aluminum. So 0.169 moles Al. 10 is 166 moles of S. 11 is 3.69 moles of Cl. That one, I might not do dimensional analysis. 12 is 0.0, which doesn't count as a digit. 0.0651 moles Na. 13 is 7.18 moles Na. 14 is 152 grams CO2. And
What was the
then
last one?
152 grams CO2. And then I can help you out. Half of these were dimensional analysis, where it's the initial line plus one step, and then a couple were initial line plus 2 steps. 10 had 2 steps, 12 had 2 steps. The rest of these were just like original setup plus one more step of dimensional analysis on the rest of the page. Anything I can do to talk you through the dimensional analysis? Anybody want to see it happen on the board? Anything on that group that went sideways?
What's the answer for 11?
The answer for 11 is 3.69 moles Cl.
I see.
Okay. Anything to 14?
How do you do 11?
11, you'd have to write the formula. So iron Fe, chlorine Cl. Iron 3 has a charge of 3 because the Roman numeral gives it away. Chlorine has a charge of 1 because it's in column 7. So that's FeCl3.
Yeah.
So what that would mean is every mole of that iron chloride has 3 moles of chlorine in it. So you
Okay.
can just go times 3.
Okay.
That one I might common sense without the dimensional analysis. But you could do dimensional analysis.
Yeah.
Something to there?
12?
12. I have a 3.45 in my first slot, a 106 even downstairs in the middle slot, and then a 2 on top of a 1 in the third slot. Do you need to know why I'm doing any of that? So I'm going 3.45 in the starter slot.
Yeah.
Then in my next one, I went 1 mole on top, 106 grams on the bottom. Then the third slot, I did 2 moles Na on top of 1 mole of mess. Because the formula for the mess was Na2CO3. Any rewind or more on that? Anybody to 14? Fifteen is like one step and out. It's 135 grams of O. 16 takes you 2 steps. It's 483 grams of K. 17 takes you 2 steps. It's 177 milligrams of K. 18 is 1 step. 2.08 times 10 to the 23 atoms of O. 19 is 2 steps. 1.92 times 10 to the 23 molecules CO2. 21 is, wait, I skipped 20. 20, did I do 20? I lost my train of thought, started to shuffle through pages. Did I say 20? Do you think so?
I don't.
Don't think so, okay. 20 is 3.43 times 10 to the 24 molecules of N2. 21 is 6.64 times 10 to a negative 24 grams of He. 21 was 2 steps of dimensional analysis. 22 is 2.33 moles, and you don't have to say what it is because I didn't say what it is. So if you said gas, fine, but you don't have to say moles gas because I didn't tell you what gas it even was. 23 is a 0.0, which doesn't count toward the digit count. 0.0263 moles O2. That had 2 steps of dimensional analysis. 24 also has 2 steps of dimensional analysis. 18.6 grams CO.
What was the answer for 15?
Answer 15 is 135 grams O.
What was 20?
20 is 6.64 times 10 to a negative 24 grams HE.
I think that's 10.
What did he say?
20.
20, sorry, 3.43 times 10 to the 24 molecules and 2. Good catch. More? Repeats, help, board, anything? Everybody's either good or shy. We both speed the class along, but shy doesn't help us any. 25 is 4.05 grams, but it doesn't say what. 26 is 12.3 grams, but it doesn't say what, so you don't have to. 27 is 1.96 grams per liter. 28 takes you 2 steps of dimensional analysis. Most of this page is taking 1, but this one's taking 2 for the first time. It's 2.81 liters HCl. 29 is 2.18 moles, just nothing else specified. 30 takes you 2 steps. It's 9.49 times 10 to the 23 particles. 31 takes you 2 steps. It's 170 liters with a bar on the 0. And then we switch mostly away from dimensional analysis. 32 is like 7th grade math-ish kind of stuff. It's 52.2% carbon, 13.0% hydrogen, 34.8% oxygen. 33 is also 7th grade mathy. It's basically, the chemistry part is setting up a fraction, but then we're turning a fraction into a percentage. So 62.4% is what we're hunting on 33. Stuff.
27.
27. So I didn't give you any numbers. So the only way you could generate a number would be working off C3H8 and using the periodic table. Which if you do that, 12 times 3, 8 times 1, that would get you 44 grams in 1 mole. So I set up the first position as a stack of 2 facts, 44 grams C3H8 on top of 1 mole. And then I did 1 dimensional analysis step. You with me so far? Since I had moles on the bottom and I don't want my answer to have moles, I'm going to put moles on the top, 1 mole on top. I like the grams. It asked for grams. I have grams. So I just need to introduce liters. So 1 mole is equivalent to 22.4 liters. So 22.4 liters is going to go on the bottom and then hit it. Is that okay?
Yeah, I get it.
More to 33. Okay. 34 is still just like make a fraction, turn it into a percentage, you know, chemistry to make the fraction, and then 7th grade to get to the percentage. 62.1% is what we're after there. 35 is a little bit of dimensional analysis, just 1 step. It's 27.7 grams mg. 36 is like a whole completely different process that has nothing to do with anything else we've done on the test to this point. That last section of homework just had a whole process to it that I can repeat. 36 we're hoping for FeBr2. FeBr2. That has nothing to do with charges, nothing to do with anything other than a math process. 37 is Na3S2. 38 is C2H2. 39 is C18H22O2. And all 4 of those have about the same process.
H what?
H22, C18, H22O2. The last one is the same process at the beginning to progress as far as CH3, which is